Hello students, I am going to interact the physics paper of 2021 in physics paper of course, and we are going to discuss all the questions and the physics behind those questions, what physics is involved, and I will start from question number 1. Here is the question number 1. Here is the question number 1. Polar molecules are the molecules acquire diplomatic dipole moment only when magnetic field is absent, having a permanent electric dipole moment. The students, you must know the polar molecules are those molecules which have a permanent dipole moment, like water molecule. So the answer that we have is second is the answer here, having a permanent electric dipole moment. That is the answer. This is the answer. Okay, now second question. The effective resistance of a parallel combination that consists of 4 wires of equal lengths, equal area, cross section, and the same material is 0.25. When I connect 4 resistors, of equal value, that's R, let me suppose R and R and R, the total resistance is R by 4, and that is given to be 0.25. That's the question. He already gives the parallel combination of 4 resistors is 0.25, and here we will get what is the resistance of a single resistor, that is 1 ohm. So if I put all these resistors in series now, the answer will be obviously 4 ohms. 1, 1, 1 and 1. The answer is 4 ohms. That's the answer to this question. Question number Question. A radioactive nucleus XAZ undergoes spontaneous decay in the sequence of this, where Z is the atomic number of element X. The possible decay particles in the sequence are. See how to solve this question. Here, this is a nucleus, and nucleus emits something, it becomes a B nucleus. But see here, it just emits a one positive charge, single positive charge. Here in the second case it emits 2 positive charges to become -3, and here it emits one more particle, that is a negative charge. So from here to here, what is the sequence? First it must emit a positive charge, 1 positive charge. Second, it must emit 2 positive charges. Let us look at the answer. First positive charge, 2 positives, because alpha has 2 positives and it is only 1 positive. So first is the answer. So XAZ, when it emits an electron, means positive electron, 0 plus 1, the resulting nucleus will be B, that is A, Z minus 1. So this is the product. But here again it emits 2 positives to become this C. 2 positives means alpha, because alpha has 2 positive charges. So this is the right choice. First is the answer. It is the question. Polar molecules are the molecules having a permanent electric dipole moment. This is the answer. Everybody should know that water molecule is a permanent dipole moment. Here this is the answer, 4 ohms. I solved it just now. So the resistors, the 4 resistors connected in parallels have the resistance of 0.25. That is given. But it will give us what's that each resistance value. That's R by 4. That's what we know. R and R parallels in R by 4. That is 0.25, and R will give us 1 ohm. If I put 1 ohm in a series of 4 resistors, I will get 4 ohms. That is the answer. This is the answer. Now the question. Column 1 gives certain physical terms this, and column 2 also gives the equations. So we had to compare drift velocity. What is the equation for drift velocity? What's the equation for electrical resistivity? What's the equation for relaxation period? And what is the equation for current density? These things. I want to give you a set of equations which will give you answers to all these questions. But we don't have to bother here to derive the equations. We have to know the base equations. The base equation is, suppose resistivity. The equation for resistivity is m divided by n e square tau. Tau is the relaxation time, m is the mass of electron, n is number density of electrons, e is the electronic charge. So from here you can just compare. You see here resistivity. Resistivity is, where is the resistivity? M by n e square tau. But tau, if you put here resistivity here, it will become the equation for relaxation time. So relaxation time C goes to P. C goes to P. And then you have one more equation, that is current, that is NEAVD. Then you have one more equation, that is voltage is equal to Ri. So from this set you can get answers to all these questions. So first of all, this electrical resistivity is this, drift velocity is this one. So you can check your answer yourself. From these equations you can get the answers. Tau is here, rho is here. So tau is here, rho is here. So relaxation time will get you to P, C to P, C to P, and A drift velocity, where A will go. Drift velocity is E, that is C. Drift velocity is R here. So let me check out. A to R, C to P. Third should be the answer. Third should be the answer. So you will get answer to all the questions from this set of equations. Okay, let me go to one more question. See here, the equivalent capacitance of the combination shown in the figure is. Here you have to apply your mind. If charge flows from here, it goes here, it goes here. From here the charge go up, and here from charge goes down. So the net charge through this resistor is 0. When the net charge through this resistor is 0, that means it will not be connected at all. So you have only two capacitors. Two capacitors in parallel, this and this. This will not be charged, this is open. So the answer is 2C. This is the answer. This fourth is the answer, because these two are in parallels, and the answer is 2C. Okay. In a potentiometer circuit, a cell of EMF 1.5 volt gives balance point at 36 centimeters of length of wire. If another cell of this replaces the first cell, then what length of the wire the balance point occurs? The question is like this. You have a battery, and I will make a potentiometer full. This is the wire, and this is the battery that you connect. What battery you connect? First of all, you connect 1.5 volt battery. And the balance point comes, means there is no current through this. Current all comes through this. That's the balance point. The balance point comes at what? That is 36 centimeters. So 1.5 volt is equal to 36 centimeters, that is the length, into current, this current, into obviously the resistance also of this part, that is, okay, maybe that is lambda, resistance per unit length. And now you connect one more, you just rub it off. You just rub it off and connect one more, that's here. That is voltage 2.5. When you connect 2.5, so the balance point may be somewhere. It should be on the other, greater side, because this more voltage needs to be balanced. Suppose it is not here. So I will write 2.5 is equal to, okay, that's the length I have to find. Current is the same because no current flows through here. It flows through the through this long wire, not through the battery. Again, lambda. If I divide, I will get this L. If you get this L is that is 36 multiplied by 2.5 divided by 1.5. If you just solve it, this gets cancelled, this, it will be 60 centimeters. This should be the answer. Now let me go to, you must understand this is the base level is very nice, there's no problem with that. You have a wire, then when you have a battery, the current should flow through this and you get a balance point. And when you connect another battery, the balance point shifts. The balance point will shift to the larger distance. Why? Because it will shift to a larger distance because it has to balance now larger battery voltage. So when you divide these two, you'll get the answer. Okay. Now, the escape velocity from the Earth's surface is V. The escape velocity from the surface of another planet having the radius 4 times that of the Earth and same mass density is. The question is, we have the Earth and you have the escape velocity from the Earth VE, that is, if you know it, that is root of 2 gm by r. But he talks about density, so we have to convert this equation into density form. So that's very easy. So escape velocity is root of 2g by r and here 4 by 3 pi r cube rho. So if you solve this, escape velocity becomes proportional to it is r square under root, it will come out as r and it will become rho inside. So you have escape velocity is proportional to r root of rho, right? This is the escape velocity on the surface of the Earth. Now, if we want to find the escape velocity from the surface of any planet having 4 times the radius, density the same, so we can use this equation. So escape velocity there on that planet is proportional to 4 times r because the radius is 4 times root of rho. So escape velocity there, it is 4, r root rho is the same as VE, so 4 times VE. That should be the answer. Correctly done by the student. Okay. Now, so here you have to learn that we have to convert the escape velocity in terms of density because we are given the density here and we are given the radius here. Okay. Now, a cup of coffee cools from 90 degrees to 80 degrees in T minutes. When the room temperature is 20 degrees, the time taken by the similar cup of coffee to cool from 80 to 60 at the room temperature, same room temperature 20 degrees centigrade. Here we are lucky enough that the range is very small, and when the range is very small, we don't have to use the big formula of that cooling, for which we have cooling, that log equation we don't need to use. Here the range of temperature fall is small, in this case also, in this case also. Here I will tell you how to solve this question. Have a look. We have Newton's law of cooling, that is dt, change in temperature per unit time, is proportional to temperature difference. This temperature is of the surroundings and this is the temperature of the body. This is the rule. Of course it is negative sign here because every time the rate of cooling decreases with time. Now what I will do is that it is dt, time, that I want to find is equal to, I will put the constant k also, that is dt divided by t minus t0. Right? Now this dt first time is t minutes is equal to k times, what is dt temperature difference in this case? 90 minus 80, that is 10. But what's the temperature of the body? Here temperature of the body can be taken as the average of the two, that is 80, 90, that is 85 minus this 20. And T dash, now T prime, now next time, that is K, what is temperature difference here? 80, 60, that is 20 divided by, what's the average of 80 and 60? That is 70 minus 20. If you divide them, what you are getting, T by T dash is equal to, this will cancel, this will go up, and it will be 50, and 50 will go up, and in the denominator it will be 85 minus 20, that is 65, and this 2 will be where? Definitely in the denominator. Definitely in the denominator, right? So you just check it out. It will be the answer will be, it is 25 here. It will be 25 divided by 65. And what is 25 by 65? It is 5 by 13. But that is T dash by T. So T dash will be 13 by 5T. That is the answer. So here we are very lucky enough to have this temperature range very small. Otherwise you had to use log formulation, which are definitely will take more time. Anyway, now let me go to the next question. Okay, a capacitor C is connected across an AC source of voltage V given by V is equal to V0 sine omega t. The displacement current I have to find. In short, I have to find displacement current. The displacement current is, have a look, displacement current. Displacement current is you can write any equation for displacement current. There are two equations for displacement current. Displacement current is, you see, epsilon 0 d pi E by dt. That is, this is electric flux. But there's nothing like electric flux given there. So you can, displacement current is always equal to conduction current. In the circuit, it's always equal to conduction current. Conduction current is equal to displacement current, because conduction current is outside the capacitor. Inside the capacitor, there is displacement current. They have to be equal in every situation. So I will write this I, that is C into dV by dt. That is C. And what is dV by dt? That you have to differentiate this. If you differentiate that V is equal to V0 sine omega t, you will get V0 omega cos omega t. Answer. That is the answer. So this is the third is the answer. So what you have to do, you have to write the displacement equation expression. It is better to write this equation, because here you have to substitute too many values, and that will get take you time. Okay. Now let me go to this question. A small block slides down an incline plane starting from rest at time t is equal to 0. Sn is the distance traveled by the block. You know what is the distance Sn? That is initial velocity, acceleration by 2 into 2n minus 1. That is the equation for distance covered in the nth second. But he writes here, what is distance covered? Sn is the distance traveled by the block in the interval n minus 1 to n. That is the nth second. And the ratio of Sn by Sn plus 1 is. This is the distance covered in the nth second. What is the distance covered in n plus 1th second? That is a by 2 into 2. N will be substituted as n plus 1. So that's 2n plus 2 minus 1. That is 2n plus 1. That is all, because you have to substitute this n per n plus 1. N plus 1, n has to be substituted by n plus 1. You will get the answer. You just divide them. And the answer will be 2n minus 1 by 2n plus 1. That is this answer. Finished. So here you need to remember the formula. Of course you must remember the formula. Distance covered in the nth second is initial velocity plus a by 2 into 2n minus 1. But here initial velocity is 0, because the body just starts sliding down the incline. Okay. Now let me go to next question. If force, acceleration A and time t are chosen as the fundamental physical quantities, find the dimensions of energy. Here we have to find the dimension of energy in these terms F, A and T. If you start doing it by the procedure that we learn in our course, it will take more time. So you check every equation. If you check every equation, and you can write the answer in less than half a minute. So let me start from first. It is F, A, T minus 1. F is force, that is m L T minus 2. A is acceleration, that is L T minus 2. And that is again T minus 1. No, this should not be the answer, because it will not match up to energy. It will not match up to the energy. Let me check this fourth, because I feel this should be the answer. It's just feeling. It is m L T minus 2 is force. It is L T minus 2 is acceleration. T square. T square and T square cancels because plus 2 and minus 2. It is m L 2 T minus 2. That's energy. So fourth should be the answer. So by this way, this technique, you can solve the question in half a minute. If you go through a procedure, a lengthy procedure that we teach to the students in the classes, वो एक derivation type, that will take you more time. So you will be wasting your time. Another question. Now, for a plane electromagnetic wave propagating in x direction, which one of the following combination gives the correct possible directions of electric field and magnetic field? First is the electric field, second is the magnetic field. Which one is the correct answer? So about electromagnetic waves, what we know? We know it is the direction, it is electric field, it is magnetic field. E cross B should be X. So in electromagnetic waves, what we know, the E and B should be perpendicular to each other. They should make 90. So here I will try a method. I will dot this and this, this and this. The dot product of any of these two, which will give me 0, is the answer. That's all. Because electric and magnetic field have to be perpendicular. If I dot these, J 1 into 1 minus 1, ये हुआ minus 1 हो गया minus 2, no. This is what you call as it is plus 1, that is 2, no. If you dot them, no. If you dot this will be minus 1 will go plus 1, or plus 1 minus 1, 0. This is the answer. So how I did it? I put E dot B, and any combination which gives me 0 is the answer. This is the shortest possible way to solve the equation, to solve this question. Otherwise there may be other methods also, but they will always take you time. So let me go to the next question. The spring is stretched by 5 centimeters by force 10. The time period of the oscillations when the mass of 2 kg is suspended by it is, we know time period, general formula for time period is 2 pi root of, okay, m by k. But k is not given, but k is force by stretch, delta x. So that is, that's 2 pi, m is, how much is the m? 2. And how much is the F force? 10. How much is delta X? Stretch. Stretch should be given 5 centimeters. 5 into 10 raised to the power minus 2. Put it here. It is 2. It cancels off. Put it here. That is 10. That will come out. And the answer should be third. 0. No, I will find the answer. Otherwise it will go wrong. It is 2 pi root of, this will go 100, 10 raised to the power minus 2. So go 2 pi by 10. That is pi by 5. That is 3.14 by 5. 5. It is 0.6, not 0.06. It is 0.6. 0.6. This should be the answer. So it is very simple. You have to start with this equation and find the substitute these parameters. Okay. Now question number. Next question. A particle released from height s from the surface of the earth. At certain height, its kinetic energy is 3 times its potential energy. The height from the surface of the earth and the speed of the particle at that instant or respectively. Question is like this, have a look. It is Earth, and here is the particle which falls from height s. It falls and falls and falls, and here it may fall some distance, and at that point it may be how much away from this surface, s prime, let me suppose. We have to find what is its speed here and how much away it is from the Earth's surface. But condition is here at this point it is velocity is, it is kinetic energy is 3 times the potential energy. That is all. So the concept is the total energy in the gravitational field remains constant. So we will write the total energy here and we will write the total energy here. That is it. So total energy here is mgs, that is the potential energy. Kinetic is 0 because it is just released, is equal to, what is energy here? 1 by 2 mv square plus mgs dash. Mgs dash here. So, but he says kinetic energy is 3 times the potential energy. So this quantity is 3 times this. So mgs is equal to, it is 3 times, it is 3 times is this, is 4 times mgs prime. Mg cancels, s prime is s by 4. So at that position it must be s by 4, but see here s by 4, s by 4, s by 4 is in 3 cases. Had it been only in 1 case, we could have taken that answer without going for the second. Now what should be the speed? So I will try to find the speed. Speed I can find like this, have a look. mgs is equal to 1 by 2 mv square plus this potential energy is 1/3 of the kinetic energy. Potential, because he says kinetic energy is 3 times, so potential energy should be 1/3 of this. So 1 by 3, 1 by 2 mv square. mv square, mgs prime plus here. So here I can write m gets cancelled throughout. It is let you multiply by 6 and 6. 6gs is equal to 3v square plus v square. That is 4v square is equal to 6gs. So v square is equal to 6gs by 4. 2 to the 4, 2 3 is 6. So v is equal to root of 3gs by 2. Root of. So 3gs by 2. This should be the right answer. So the concept was very simple. What was the concept? You just release an object. Total energy here is equal to total energy here. Then you substitute what is given. The given was the potential kinetic energy is 3 times the potential energy, and we could do this. It is 3 times, it is 3 plus 1 times 4 times. So that solves the question. Now here is the question. A lens of large focal length and large aperture is best suited for as an objective of an astronomical telescope. Everybody should know it. So large aperture contributes to quality, visibility. Large area of the object ensures better light gathering by the power. More is the area and more is the light it gathers to have a better image. So large aperture. So this must be the answer. Two charged spherical conductors radius r1 and r2 are connected by a wire. The ratio of surface charge densities of the spheres ρ1 by ρ2 is. So here we can solve this question like this. It is a sphere of radius r1. It is a sphere of radius r2. Now I am okay. Let me suppose it is charge q1. It is charge q2, and I will connect them. When I connect them, immediately you should realize that potential becomes the same. What is potential here? In this case, for this sphere, that is 1 by 4 pi epsilon naught q1 charge, but I will put that into charge density. That is 4 pi r1 square sigma. That is charge, surface area into sigma by R1. That is what you call as the potential on this conductor, right? Now what is the potential on this conductor? That is 1 by 4 pi epsilon naught 4 pi R2 square sigma 1 put here, sigma 2 here, and R2. So this cancels off, 4 pi cancels off, R1 cancels off, R2 cancels off. R1 sigma 1 is equal to R2 sigma 2. So what is sigma 1 by sigma 2? That is R2 by R1. That should be the answer. R2 by R1 should be the answer. That is this answer. It has been wrongly done by the student. He has put it here, but it's the actual answer is this. Okay. Now let me go to another question. A convex lens A of focal length 20 centimeters and a concave lens B of focal length 5 centimeters are kept along the same axis with a distance d between them. If the parallel beam of light falling on A leaves B as parallel beam, then distance d in centimeters will be. The question is like this. You have two lenses, convex lens and concave lens. Here comes the parallel beam. It may bend downwards, but again when it passes this, it goes parallel. That means focal length of the whole combination is infinity. Because the ray does not meet the principal axis, it goes parallel to infinity. So focal length is infinity. For here we know, what we know is 1 by focal length of the whole combination is 1 by f1 plus 1 by f2 minus d by f1 f2 is equal to, it is the total focal length, that is infinity. So 1 by infinity becomes 0. If you solve this, it will take a while. Okay, I will solve it for you. That is 1 by f1, that is 1 by 20 plus 1 by f2, that is concave, that is minus 5 plus minus d by f1 f2, that is 20 into minus 5 is equal to 0. So here it is 1 by 20 minus 1 by 5 minus d by plus d by, it is 20 into 5, that's 100 is equal to 0. That is d by 100, put it on the other side, 1 by 5 minus 1 by 20. Yeah, when I put these two on the other side, so d by 100 is equal to, it is 20 LCM, it is 20 here, 5 here, is 4 here, minus, that is 3 by, that is 5 into 4 is 4 minus 1, 3 by this, that is d is equal to 3 times into 100 by 3 times into 100 by 20. That cancels, you go 2, 5. 15 should be the answer. That is this thing. Correctly done by the student. Again, let me repeat you. Two lenses in a combination. You have a formula for the total focal length. 1 by f1 plus 1 by minus d by this. You can substitute the values. But here, the information that he gives you is that the ray of light again goes parallel to the principal axis. So that indicates that the total focal length is infinity. So here 1 by infinity minus means 0. So you can solve this question like this. Okay, let me go to this question. An infinitely long straight conductor. Okay, let me make it infinitely long conductor carrying current I is equal to 5. Then what does he say? Electron moving with the speed of this parallel. Here is the electron moving parallel. 10 raised to power 5. The perpendicular distance, the distance is 20 centimeters. Calculate the magnetic force. This conductor will create a magnetic field in circles around. So that magnetic field will be inwards. So magnetic field and direction, velocity direction is 90 because it is inward magnetic field. So there must be force. So what is the force equation on the electron? That is F is equal to Q V cross B, but is the VB because angle is 90. So F is equal to Q is electronic charge, that's 1.6 into 10 raised to power minus 19. Velocity is 10 raised to power 5. And B, that is magnetic field due to this, that is mu 0 I, that is current, by 2 pi r 20 centimeters, 20 into 10 raised to power minus 2 centimeters. You have to calculate this. The answer will be, I think it is 4 pi into, substitute this 4 pi into 7. Mu 0 is equal to 4 pi into 10 raised to power minus 7. You have to substitute this mu 0 also. This mu 0 should also be substituted. Right? When you substitute mu 0, I think pi will not remain because 2 and 2 will, there will be no pi in the upper side. There will be no pi. So this cannot be the answer. This cannot be the answer. These two, any of these two can be answered. So I have to see. 1.6 into 5, 8. Yes, this is the answer. If you substitute the values, say 1.6 into 5 means 8. So I just say it is 8. Rest will take care of itself. 2 pi has gone. So let me go to the question number. The question is, you have a conductor, you have a point here, the magnetic field be produced here, the electron is in the magnetic field, it is moving with a velocity, and you already know when a charge is moving in the magnetic field, there it experiences force. And that force is F Q V cross B, but here it will be Q V B, because V and B are perpendicular to each other. So B is the magnetic field created by the conductor. Substitute all the values, get the force on the electron. Okay, now let me go to, if E and G respectively denote the energy and gravitational constant, then E by G has the dimensions of E by G. What are the dimensions of E by G? If you substitute E, energy, and G from somewhere, you have to get G from somewhere, and because there also you have to substitute G. Possibly you will get the answer, but it will take you more time. So I will do something about it. You have an equation, potential energy equation. Energy is equal to minus G m small m by r. This is the expression for gravitational potential energy. So here energy is the same as this. And G you get down to this. So U by G, that is the energy by gravitational constant here. So that is m square by r. That is m to L, because R is L, length, minus 1, T 0. That should be the answer. Correctly done by the student. So here it is the shortest way of doing the things. You just remember your one of the formula of gravitation. U is equal to minus G m small m by r. U by G, energy by gravitational constant is m square by r, because it is m into m, that is m square by r, and you will find the answer. Here, the velocity of a small ball of mass m and density d when dropped in a container filled with glycerin becomes constant after some time. If the density of glycerin is d by 2, then the viscous force acting on the ball will be. The question is, a ball is falling in the glycerin, and finally its velocity becomes constant. When its velocity becomes constant, that means the net force on the ball is 0. That is all. So when the net force on the ball is 0, but we have to find what are the forces downwards. mg. What are the force upwards? Buoyancy force plus viscous force, neta force. So these two forces have to be equal. But buoyancy force is mg by 2. That I will tell you how. Because he says density is half the density of the ball. When the density is half the density of the ball, that means the ball will displace how much weight? mg by 2. The weight, जो इसका weight अपना होता है, उस वेट का आधा ये फ्लूइड डिस्प्लेस करेगा, उस वेट का आधा ये ग्लिसरीन डिस्प्लेस करेगा. It is only because the density of the glycerin, the question asks is half the density of the object itself. So you can do it like this. So F neta plus Fb is equal to mg. So F neta is equal to mg minus this will go mg by 2. That is mg by 2. That is the answer. This one is the answer. Okay, let me go to another question. The electron concentration in n-type semiconductor is the same as hole concentration. External field electric is applied. So why the current in n-type is greater than the current in p-type? I think this should be the answer. Because although the density concentration of electron hole concentration is the same, that's it. Hole concentration and electron concentration is the same, but you must not forget that electron has more mobility. When you apply electric field, its drift velocity becomes more. So current, as you know, that is NEAVD. Because electron has more mobility, therefore this is more. So I think this must be the answer. Concentration current in n-type is greater than current in the p-type. Answer is this from here. The electron mobility is more, therefore electron drift velocity is more for the same electric field or for the same potential. You apply potential difference. The current in the n-type will be less, n-type will be more because electron will move faster as compared to the hole, because electron mobility is more than the hole mobility. That is the answer. Okay. A thick current carrying cable of radius r carries a current I uniformly distributed across its cross section. The variation of magnetic field due to the cable with the distance r from the axis of the cable will be. So I think this must be the answer. I will explain you that. The explanation is something like this. It is a current carrying conductor. It's a current carrying conductor, and here at R the magnetic field from the axis at the axis is 0, and from axis onwards to the surface it increases. When it increases linearly, so I will get the equation B is equal to mu 0 I by 2 pi r square small r. So it increases as small r. So graph should be like this up to the radius. From onwards, when it goes out, the magnetic field decreases as 1 by r, because outside formula is mu 0 I by 2 pi r. So it goes like this. It goes like this. This is the answer. So this one is the answer. First, it's a conductor from the axis towards the surface, it increases r, and from the surface onwards it decreases 1 by r. So that must be the answer. Next question. A screw gauge gives the following readings when used to measure the diameter of a wire. Main scale reading is 0. So it has no 0 correction. Circular scale reading is this. And 1 millimeter on the main scale corresponds to 100 divisions. 100 divisions is equal to 1 millimeter. That is given. So what is the answer for the diameter? So diameter should be equal to 52 divisions, nothing, because there is no zero correction. 52 divisions. But what is 1 division? 1 millimeter by 100. That is 0.52. But millimeters, that is 0.052 centimeters. This should be the answer, not this. It is so simple. These divisions is the diameter, but 1 division is given to be this, because 100 divisions he says 1 millimeter. If you have seen screw gauge and you just wind it, so 100 divisions means if you make a 1 revolution of 100 divisions, it will go 1 millimeter for, it will advance by 1 millimeter. If you have seen the screw gauge. This is the question. The number of photons per second. The number of photons per second on an average emitted by the source of monochromatic light, wavelength 600 nanometers, when it delivers a power of 3 into 10 to the power minus 3 watt, will be, H is given to be this. What we have to find? We have to find the number of photons per second, which will produce this much of power. That is all. Photons are coming and they are impinging on some target. We have to see that delivers a power of given power of this. So how many photons per second is emitted by the source, or how many photons are received by the surface per second. That's it. You have an equation, simple basic equation. Power is equal to energy by time. Energy is equal to photon energy, that is h nu, but n times by delta t. This is n by delta t is number of photons emitted per second. So let me call this n by delta t n prime is equal to p divided by h nu. That is p by h c by lambda. Lambda will go up, that is p lambda by h c. This lambda will go up here. So I had to substitute this, this and this. Let me substitute. Let me see, can I get the right answer? Okay, p lambda by h c. Let me remember this. P lambda by hc. What is P? Okay, I had to substitute for P. P is 3.3 into 10 to the power minus 3. I want to solve it here only. It is n prime is equal to, what is P? P is 3.3 into 10 raised to the power minus 3. That is the P. Lambda is 600 nanometers, that is 600 into 10 raised to the power minus 9. H is given to be 6.6 into 10 raised to the power minus 34. And what is C? C is 3 into 10 raised to the power 8. That is the velocity of light. If I do it, it gets to, it is finished here. So it's only tens are, there remain only 10, but there are all tens. So I have to see. Had I known the answer, I would have given you the answer directly, but I don't know the answer. Okay. That is 10 raised to the power minus 3 plus 2, these minus 9 plus 34 minus 8. Eight plus 9, 17, 20. 10 raised to the power minus 20 plus 34. So out of 34 you get, out of 34, 20, that is 4, 1. 10 raised to the power 14. There's no answer like 10 raised to the power 14. We'll check it again. Let me check it again. It is n is equal to n prime is equal to 10 raised to the power minus 3 here. Then it is plus 2, these 2 zeros, minus 9 plus 34 plus 34 and minus 8. So it is 17, 18, 19, 20, 10 raised to the power minus 20, but 36, 4 plus 2. 34 plus 2 means 36. That's 10 raised to the power 6, 1, 16. This must be the answer. I'm sorry, I could not collect all the zeros. So the question is very simple. You have to start with P is equal to delta E by delta T. That is all. But here you have to write delta E is n times h nu, number of photons into energy of a single photon by delta T, and then you go forward and solve the question. Now let me go to another question, that is water falls from a height of 60 meters at the rate of 15 kg per second to operate a turbine. The losses due to the frictional force are 10% of the input energy. How much power is generated by the turbine? That's what we have to do. So again, what's power? Energy by time, base equation. how much energy the water falls. That's mgh. That is the energy by waterfall. When water falls or anything falls, it has an energy when it comes onto the ground. The energy it has depends on from where it falls. It must fall from certain height. It has an energy. When it falls, that energy gets converted to some other form of energy. But 10% is gone. 0.9 of this energy is available. Because 10% energy is gone, so what remains? 90%. So 0.9 of mgh by delta T. So power is equal to 0.9. What is m by delta T? That is mass per unit second. That is 15. What is g? That is 10. What is h? From where it falls? That is 60. If you multiply them all, you must get the answer. That is 15 into 9. 15 into 9. That is 9. It is 6 into 15. That is again 9. This must be the answer. You can check it out. I did the answer like this. I multiplied 6 into 15. That becomes again 9. 9 into 9, 90, 81. So this must be the answer, because there is no other figure which compares with this equation. Or you can just write it down and multiply yourself to get the right answer. Okay, let me go to another question. An electromagnetic wave of wavelength lambda is incident on a photosensitive surface of negligible work function. If m is the mass of photoelectron emitted from the surface, has de Broglie wavelength lambda d, then question is, it's a surface and photon comes, it emits an electron. There's no work function available. So I can write an equation where, okay, what is the kinetic energy of the electron? The kinetic energy of the electron is simply the energy of the photon, because there's no work function to be wasted off in between. This is the base equation. Now here I can write kinetic energy p square by 2m also is equal to h. Here new frequency, that is I will write c by lambda. And then I have to find, what should I find? I will find lambda. Okay, I will find lambda because lambda is in 3. Lambda d is only at one place. And then I will see what should be the right answer. Okay. That is p square by 2m is equal to h c by lambda. P 1 by 2m, but p square according to de Broglie is h by lambda d. De Broglie wavelength. So that is h square p square, because it is lambda d square is equal to h c by lambda. H gets cancelled. So what should I find? Should I find lambda or lambda d? Okay, I will find lambda. Let me see. If it does not fall, it should be the answer should be the last one. Okay. Now h gets cancelled, so lambda is equal to this one. That is 2mc lambda d square, this also here, by h. 2mc by h into lambda d square. Let me check out the answer. 2mc is either here or it is here. 2mc by h lambda d square. Okay. 2mc by h lambda d square. 2mc by h lambda d square. 2mc by h lambda. This one is the answer. Okay, let me go to another question. Match the following. Choose the correct match from the given choices. This matching business, so I have to write down the equation where from you can write your good. So I will try to find you the correct answer. Now see here. He says pressure, and then he says pressure exerted by the gas, average kinetic energy, total internal energy he talks about. So I will write down the equations, all the equations. Pressure, as you know, is equal to 1 by 3 rho v square RMS. This is one equation, but you can convert this into another thing. That's very simple. Kinetic energy per molecule is equal to 3 by 2 kBt. If it is degrees of freedom, then I is this 3 is equal to I, number of degrees of freedom. Degrees of freedom by 2 kBt. It's a kinetic energy for a single molecule. Achha, for 1 mole, it is I by 2 RT. 1 mole, kinetic energy for a mole. Now let me try to get the correct answer. Root means square speed of the gas molecules. Root means square speed of the gas. It should be Q. It should be Q. Root means square. It is A. Then pressure exerted by the ideal gas. It should be P. It should be P. It should be this P. So first is the answer. Let you check out. Okay, I will write C also. Average kinetic energy of a molecule. This should be the answer, S. Yes, S. Then D, total energy of a diatomic. Diatomic means I by 2 R. I is 5 for diatomic. Go 5 by 2 R. So everything is, from this you can just answer all the questions. This equation, this equation, this equation, and this equation. And first is the answer. Now here, a nucleus with mass number 240 breaks into 2 fragments, each of mass 120. The binding energy per nucleon of a unfragmented nuclei is 7.6 MeV, while that of the fragments is 8.5 MeV. The total gain in the binding energy in the process is, I will explain. It's a nucleus. It splits, becomes 2 nuclei. The parent nucleus has a mass number of 24. It has 120 and it has also 120. Mass number is conserved. Mass number is quite conserved. So when mass number is conserved, here what is the binding energy here? That I will write. What is binding energy for these two? That I will write. What is binding energy for the parent nucleus? Binding energy for the parent nucleus is 240 into binding energy per nucleon is 7 into 7.6. Because it is binding energy per nucleon, but you have so many nucleons, 240. What is binding energy here? 120. What is binding energy per nucleon of the fragments? 8.5. But you have to multiply by 2 because they are 120 into 8.5 into 2 because there are 2 nuclei. This is the total binding energy of the fragments. This is the total binding energy of the parent nucleus. You subtract the 2 and get the answer. So I will write down change in binding energy. That is 120 8.5 into 2 minus 240 into 7.6. If you substitute this, you will get the answer. So possibly this is the answer. You can check it out. You can check it out yourself, and I think 216 MeV must be the answer that you can check out. Now, a parallel plate captures a uniform electric field E in space between the plates. If the distance between the plates is D, the area of each plate is A, the energy stored in the capacitor is. Here we have to find how much the energy stored in the capacitor. You know the energy is stored in the form of electric field. That's what you know, that's what anybody else knows. The energy is stored in the form of electric field. So you can just write, anybody knows the energy is 1 by 2 CV square. That's anybody's guess. But you can substitute here 1 by 2, here you can substitute epsilon 0 A by D, then you can write voltage is electric field by D, electric field into D whole square, electric field into distance, that is 1 by 2 epsilon 0 E square, here it is D square, 1D gets cancelled, A is numerator, here 1D also denominator, this must be the answer. This must be the answer. So this equation is the base equation from where you can start and solve the question. Okay, now let me go to this question. Find the value of the angle of emergence from the prism. Refractive index of the glass is √3. Here the ray of light will go straight here, and here it will go out and bend here. I have to find this angle, this theta. Here it is 60, it is 30. It is 30, it is 60, this one, and therefore it is 30. Here it is mu, that is root 3. I will use Snell's law from here to here. The refractive index of this space around is 1. From here to here I will use a Snell's law and get the answer. Root 3 sine of 30, here, this one, is equal to 1, that is the refractive index of the outside medium, sine theta. You go root 3 into 1 by 2 is equal to sine theta. So sine theta is equal to root 3 by 2, that was sine 60. Theta is equal to 60. That is your answer. That is your answer. This one. Now let me go to another question. A dipole is placed in the electric field as shown. In which direction will it move? Now see, here is a very typical question. These are electric field arrows. When you look at these arrows, electric field here should be more, here it should be more, here it should be less, because the density of field lines here is less, density of field lines here is more. So this plus q is in the higher field, this minus q is in the lower field. This charge will experience force in this direction. This negative will experience force in this direction in the electric field, because positive charge will experience force in the direction of electric field, negative charge opposite. But which of the two forces is larger? Which of the two forces is larger? The force on the positive charge, because that is at the higher field level, higher field side. So this force is more, this force is less, so net force is this way. That is the answer. So it must go towards the right. Towards the right, this is the answer. So let me explain once again. This charge is at the higher field side, this charge is at the lower field side. It will experience more force to the right, it will experience less force to the left, so net force is to the right. Okay. Now consider the following statements A and B and identify the correct answer. A Zener diode is connected in reverse bias, that's true. Zener diode is always connected in reverse bias for voltage regulation. It's a statement of fact. The potential difference of PN junction lies between 0.1 and 0.3. That's the wrong statement. Why? Because potential difference of the PN junction is of the order of 0.5. It goes from 0.3 to 0.7. For silicon it is 0.7. For germanium it is 0.3. So there's no question of 0.1 to 0.3. So A is correct. A is correct and B is incorrect. A is correct, B is in. So he has given a wrong answer. This is the answer. The half-life radioactive nuclei is 100 hours. The fraction of original activity that will remain after 150 hours is, you see, so many radioactive equations from chemistry, from physics. You can start with any equation you like. Within 2 steps, or maybe 2.5 steps, you can just get the answer. We know the base equation. We know the activity is proportional to n, or activity is equal to lambda n. That's the base equation. From here, going 2 steps, we can write R, activity after any time, by original activity, activity at t is equal to 0, initial activity is equal to 1 by 2 whole raised to n half-life periods. T by t0, t by t, it is t half-life. So it is 1 by 2 whole raised to power. What is t? Total time? 150 hours. What is half-life? 100 hours. 0 cancels. It is 1 by 2 whole raised to power 15 by 10. That is 3 by 2. So it is 1 by 2 raised to power 3 by 2. 2 raised to power 3 means 8 by 2 means root. That's root 8. That is 2 root 2. You can check it out for yourself. 1 by 2 whole raised to 3 by 2 is 1 by 2 root 2. That is the answer. Now let me go to this question. This is the question. It is inductor, it is capacitor, it is resistor, and we have to find the amplitude of current. Yes, the amplitude is given to be of current is given, the impedance of the circuit. I want to give you a simple equation for impedance. Anybody can remember this. Impedance is peak voltage by peak peak current. But peak voltage is not given in the circuit. What is given, what we can find in the circuit is root mean square voltage by IRMS. What is root mean square voltage? That is root of VR square plus VL minus VC whole square by IRMS. But here he gives peak current, but we need only RMS current. That is only 10. Because RMS current is peak current by root 2. That cancels with this root 2. So here it is VR square is what? What is voltage across the resistor? 40. 40 square. 1600. Plus VL. That is 40. VC. That is 10. That is 30. 30 so 900. By 10. That is 2500. That is 50. By 10. That is 5 is the answer. 5 is the answer for this question. That is the 5 ohm is here. This is the rule, because when you apply voltage across the AC voltage across inductor, resistor and capacitor, you don't write the sum of the voltage V1 plus V2 plus V3. No, you write root of voltage across the resistor square plus voltage across the inductor minus voltage across the capacitor, square of that, and you get a root of that. Because in case of AC circuits, there's a phase difference between current and voltage in inductor, in capacitor, in resistor. So you can't write a simple equation as in DC, sum of the three voltages. So here VRMS applied is not 40 plus 10 plus 40. No, it is root of 40 square plus 40 minus 10, that's 30. Square of that, root of that. So you may have learned that in your classes, but I will solve this question like this. Okay. Now, a body is executing simple harmonic motion frequency n. The frequency of its potential energy is. Simple harmonic frequency is n. What is the frequency of potential energy? I will explain you by two methods. I will give a mathematical equation, and then I will physically explain. See here, a particle is oscillating back and forth. It go from here, it goes here and comes back. So one time period. From here it goes here and comes back one time period. In one time period, what does the particle do? It goes here and here potential. It goes here and here potential energy is maximum at the extreme position. Comes back here again potential energy is maximum. So it achieves maximum values of potential energy. It achieves maximum value of potential energy twice in single oscillation. So that means its frequency must be twice that of the simple harmonic motion. Kinetic energy also twice. From here kinetic energy maximum, from back kinetic energy maximum. From here to here and back here is one oscillation. In one oscillation it achieves maximum kinetic energy, again maximum kinetic energy twice, 2 times. So whether it is kinetic energy or potential energy, the frequency has to be 2 times. Okay, so answer must be this. Mathematically, you know potential energy, if you remember the equations. I don't know how much you remember of what you have done earlier. So it is proportional to sine square. It is proportional to sine square. Potential is 1 by 2 kx square. Kx you substitute sine square. Okay, omega t. Here nt, because n is frequency. Here you can convert this square into cos function. That is 1 minus cos of 2nt by 2. So frequency is given by the cos function. Cos के सामने 2n है, therefore 2n is the frequency. जो cos के सामने ये coefficient है 2n, that gives you the frequency. So mathematically you can do it like this, or physically you can know, well, potential energy achieves maximum value twice in one oscillation. So whether it is kinetic energy or potential energy, the frequency will be twice. Okay. Here, from a circular ring of mass m and radius r, an arc corresponding 90 degrees sector is removed. The moment of inertia of the remaining part of the ring about an axis passing through the center of the ring perpendicular to the plane of the ring is k times mr square. Then the value of k is. The question is like this. It is a ring. Okay, let me say the moment of inertia of the ring is I. Is it ring or it is? Yes, it is the ring. It is mr square, that is everybody knows, potential and this moment of inertia of the ring. Now what we do is, you cut one piece and find the moment of inertia of the remaining 3 pieces. What is moment of inertia of the remaining 3 pieces? I prime is equal to, okay, total moment of inertia, that is mr square, minus moment of inertia of this piece, that's how much? Mr square by 4. No, if the moment of inertia of the total is this, the moment of inertia of 1/4 of it is mr square by 4. So total moment of inertia minus moment of inertia of this piece will be the moment of inertia of the remaining. So I prime is equal to 3mr square by 4 is equal to, given to be k times mr square. So k should be equal to 3 by 4. That's the answer. Whole disk mr square, take a part of the disk, 1/4 of it, that will decrease the moment of inertia mr by 4 because it is symmetrical case and moment of inertia at this level is scalar. So you don't need to bother about. So the answer gives k is equal to 3 by 4. Now, a series LCR circuit containing 5 Henry inductor, 80 microfarad capacitor, 40 ohm resistor is connected to a 230 volt variable frequency AC source. The angular frequency of the source at which power transfer to the circuit is half the power at the resonant frequency, resonant angular frequency, or likely to be, says likely to be. So this is the question which will definitely take more time, but I want to give you a concept which will solve it in a very short time. See here the question, let me explain the question in full detail. The question is like this, you see, have a look. This is power versus frequency. Time like, very time like. Okay, now see here, let me go to this question again. Series LCR circuit where you have 3 elements like inductor, capacitor and resistor, and you apply AC source and you are getting power. You are getting power, and he says, what are those 2 frequencies at which power delivered to the circuit will be half the maximum? Will be half the maximum. So the graph is like this. The graph is like this. Here is the maximum power, P max, and half the maximum means this, P max by half. We have to find these 2 frequencies, omega 1 and omega 2. These 2 frequencies we have to find. So there may be a method like this. You see, I will find phase difference that is tan phi is equal to omega L minus 1 by omega C by R. I will substitute the values, find this, and finally it will become a quadratic equation in omega. And once it becomes a quadratic equation in omega, and then I will get the 2 values of omega, and that will be this value and this value. But definitely and certainly that will take me more time. So I will do it other way around. See here, there's a concept that this is bandwidth. Omega 2 minus omega 1 is bandwidth. And bandwidth is defined at the power half the maximum. At half the maximum power, the 2 frequencies at which the power delivered is half the maximum is bandwidth. Difference of the 2 frequencies is just bandwidth. So bandwidth is defined as the difference of the 2 frequencies at which the power delivered is half the maximum. So why not find omega 1 minus omega 2? If I find omega 1 minus omega 2, that is certainly from the procedure, that is R by L. R is, I have to find what is R. I have to see what is R. R is 40, yes. R is 40, and this L is 5, 8. So the difference of the 2 frequencies must be 8. This is the procedure through which we can solve this problem in a minute, otherwise it's not possible. So the difference of the two frequencies, which defines also the bandwidth, is just what? 8. Now let me go to the question and see. 54 minus 46 is not 8. 58 minus 42, that we have to see. 75 minus 25, that we have to see. Wherever difference is 8, we'll get the answer. Let me see first, is it 8? I told you it is not 8, but maybe it is 8. 54, 46, it is 8. Yes, first is the answer. So this is the only possible way where the question can be solved in a minute. Otherwise, if you make it a quadratic in omega, you will get two values of omega after a certain procedure. It will be alright, but finally you will get the answer, but it will take you more time. Okay, this is all done. Let me go to the question number, next question. A uniform conducting wire of length 12A and resistance R is wound up as a current carrying coil in the shape of an equilateral triangle of side A and a square of side A, but 12A is the total length. So what is the magnetic dipole, magnetic moment? So it is like this. First it is a triangle like this, then it is a square like this. Triangle, each side is A. It is A, it is A, it is A. Here also it is A, it is A, it is A, it is A. But how many turns it needs? It is 12A. It is 4 turns it needs here. 4 turns will make it 12A total, and here 3 turns we need to make it 4A. Here it is 4 turns, current I flows. So what is the magnetic moment here? M1. Magnetic moment is current into area. 4 times. 4 is the number of turns. I is the I. So what's the area? Area is 1 by 2. Base is A. Height is A cos 60. That is A sine 60. So go A root 3 by 2. 2 cancels with 4. You go A square I A square root 3. I A square root 3. This is the only choice. ये निकालने की जरूरत नहीं है. You don't need to find this because root 3 A square I is the first choice, and in other it is not. If you want me to, I'll find this. It is 3 times I A into A area A square. That is the second, this one. That's the answer. A step-down transformer connected to AC mains supply of 220 volts is made to operate at 11 volt 44 watt lamp, ignoring power losses in the transformer. What's the current, the primary? So there's a transformer, there is input, there is output. So what we know of the transformer, when there are no power losses, input power and output power is the same. So input, output power is the same. So you can use the equation. What's the input current? Okay, that I had to find. What's the input voltage? There's 11 volt. That's the power. That's 44. Watt. But this is not the voltage. Voltage is this. I'm sorry. So it is voltage is 220. So I is equal to 4 by 220. That is 0.2 amperes. That's the answer. Okay, now let me go to 27 drops of same size are charged at 220 volt each. They combine to form a bigger drop. Calculate the potential of the bigger drop. We have little droplets or little drops, so you combine them to form a bigger drop. We have to find the potential of the bigger drop. Potential of the little drops we know. Yes, 220. So how to do it? Well, you must know when your drops combine. When they combine, what remains constant? Charge, conserved, and volume. That is all. So it can be done on that concept. Little drop, its radius is R. Let me suppose. How many drops combine to form the big drop? 27. So what is the volume of the 27 drops? 27, okay, it's 4 by 3 pi R cube. That is the volume, is equal to volume of a single big drop, that's 4 by 3 pi R prime cube. This cancels off, so R prime is equal to, okay, 27, that is 3R. That is R prime. Now, what's the potential of the bigger drop? The potential of the bigger drop is 1 by 4 pi epsilon naught total charge. Yes, total charge is the charge of the single drop be q. So total charge is 27q divided by radius of the, that's 3r, 39. That is 9 times 1 by 4 pi q by r. That is the potential of a single drop. 1 by 4 pi epsilon naught q, single charge drop, by radius of that drop is the potential of that little drop. So that is here 1 by 4 pi q by r, 9 is here, so that is 220. So it must give you the answer. This must be the answer. Two conducting circular loops of radii R1 are placed in the same plane with their centers coinciding. If R1 is greater than R2, the mutual inductance M between them will be directly proportional to. We have two coils, one coil and second coil. Their planes coincide. They have the same planes in the same. The two planes are in the same plane, and their centers also coincide. So, what is the coefficient of mutual inductance? Have a look. This is the one coil, this is the second coil. Big radius is okay R1, little radius is R2. It is current I, let me suppose I1. This current I1 proves magnetic field here at the center. So how much magnetic field it proves at the center, which passes through the inner circle? That is okay. What's the flux through the inner circle? That is magnetic field here in the inner circle, that is produced by this. So I want to do something like the magnetic field of the outer passes through the inner. So I had to find the flux through the inner, that's phi 2. That will then I will give you the relation how it is done. So it is magnetic field, that's mu 0 I by 2 pi r1 of this into pi r2 square, because that is the area of this. So phi 2 is equal to m times I1. This is I1. What is M? Because flux to the secondary is proportional to the current in the primary with a coefficient of mutual induction connected in product form. So M is what now? Proportional to, don't write these things, only R2 square by R1. This is the answer. R2 square by R1. This one should be the answer. A particle of mass is projected with the velocity of this from the surface of the earth. V0 is V is the escape velocity, the maximum height. So the question is something like this. It is earth and you are projecting a particle with velocity V is equal to KVE. Where it will go? That is the question. Either you have to use the energy expression, conservation of energy, or you can guess the equation H is equal to R divided by V escape square by V square, that you give minus 1. It is R divided by, what is V escape? That is V escape square by, what is V? That is K square V escape square minus 1. This cancels off. So R by 1 by K square minus 1. That is R K square divided by 1 minus K square. That should be the answer. This one. You can use directly this formula, or then you can use the conservation of energy principle from here to here. Both will do. Okay. A uniform rod of mass 200 centimeters and mass 500 kg is balanced on the wedge 40 centimeter mark. A mass of this suspended. Okay. Then you have 160 here. Then you have to find the value of M. You have to find the value of M for that to be balanced here. Rod has a mass of half a kg, 1 by 2 kg. At what distance? Yes, it is total distance is 200. So from here to here it must be 100. So it must be at 100 at the center. The mass acts at the center. It balances under all these forces. It balances here. So we had to sum the moments about this point. Are the moments on this side should be equal to moments on this side. What is moment on this side? That is 40 minus 20, that is this distance. That is 20 into 2 on the left side. On the right side, that is 1 by 2 kg into 100 is here minus 40, that is 60 distance, this distance, and plus m into how much away it's from here, 160 minus 40, because 40 is the mark here, that is 120. If you solve this equation, it is 30 minus 40, that is 10, is equal to m into 120. That's m is equal to 1 by 12. That should be the answer. 1 by 12. So what you do is that you balance it at this point. These moments go to these moments, but here you have to apply your mind. The mass of the rod was not mentioned here in the figure, but you have to do it like this. If you do it without mass, then you will get a wrong answer, like any other answer which will be ready there. So it will deceive you. If you don't consider this mass, it will deceive you, and you will get the answer that will be ready for the deception, and you will tick that answer. A ball of mass 0.1 kg is dropped from a height of 10 meters, strikes the ground, rebounds to the same height. The magnitude of impulse input is given by. See here, a ball is dropped from height of 10 meters. It hits the ground. It has a velocity v, comes back with the same speed. Of course, the velocity changes, but same speed, goes to the same height. That means it has not lost any energy here. So that means it will come back with the same speed. Once it rebounds, it comes back with the same speed. This. The choice is, you see, to do it by many methods, but the simple method is, what is change in momentum? mv is the forward going momentum and mv is the backward coming momentum, but the direction is different. This momentum is forward coming moment, downward coming moment, this upward coming moment. If you subtract the two momenta, you will become 2mv. Delta p is equal to 2mv is root of 2gh. It is 2 m given the value of 0.1 kg, root of 2 into 10 into what is h, how much height, 10 meters. If you substitute them, it is 3 here, it is 3 here, and then it's 10, 3 here. Yes, it is 4.2 answer. You can guess the answer. It is 0.1, 0.2 is 0.3, 0.3 to 10 is 3, 3 root 2 is 4.2. Okay. Now, a particle moving in a circle of radius r with a uniform speed takes time t to complete one revolution. If this particle were projected with the same speed at an angle theta to the horizontal, the maximum height attained by it equals 4r. The angle of projection theta is given by. I had to work it out. The problem has to be worked out. Okay. You see, a particle moves in a circle of radius r. What is the speed? What is the speed? Does it give the time period? Yes, let me see. Oh, yes, time period is given. So, time period is 2 pi r by speed. Speed is equal to 2 pi r by t. Okay, I have found the speed. Now I am projecting a particle at an angle theta so that it goes somewhere, but vertical height is 4 times this radius. I have to find what is this theta equal to. You know, vertical height h is equal to v square sine square theta by 2g. That's what you know. Now here I will substitute v square, here I will substitute 4r. That means 4r is equal to v square, that is 4 pi square r square by t square. 4 pi square r square by t square. This one sine square theta by what? By 2g. This 4 gets cancelled. Sine square theta I will write. 2g will go there. 1 hour will get cancelled. Yes. 2g will go there with t square. Yes. 2g t square will go there. Divide will be pi pi square r. Yes. Yes. Theta will be sine inverse root of, because sine square theta is this, sine theta will be root of this, that will be 2g t square by pi square r. 2g t square pi square r. 2g t square pi square r. This one should be the answer. 2g t square pi divided by pi square r. Yes, this one should be the answer. Okay. Okay, now this question. For the given circuit, the input digital signals are applied at the terminals A, B, C. What would be the output at the terminals? These are the outputs. We have to see the correct answer. And it has to be done within a minute. Now see here. It is a AND gate. A or B ka A AND gate. It's A dot B. It is B or C ka NAND gate. So A, B NAND C. This is OR of these two. That's A and B, or B and B and C NAND. NAND. This is the equation I have, output equation A, B, or B, C. Right? Now I will check it only for two inputs. Rest will go, because two inputs are not the same here in three cases. I'll find only for the two, and then the answer will be clear. I will find only for two inputs. If two inputs are the same for 2 or 3, then I will go for the third input. Otherwise, two inputs will suffice. Now, what is A here, B here, C here? So it is A is 0, B is also 0, B is 0, C is 1, because it is higher voltage 1. It is 0 or 0, 0 and 1 is 0, inverted NAND, that is 1, that is 1. So I have higher input. Higher input is where? This is higher input, this is higher input 5, this is higher input, this is higher input, this is lower, and this is lower 0. So that means these two, I have to make choice between these two. अब आगे जा करके this is lower but this is again higher. Let me check for the second. Second is, have a look. Second is A, B, C. What is A? That is 1. B, again 0. B, 0. C, C is 1 bar. It is 0 or 0 and 1 is 0 bar 1. It's again 1. But here it is lower. It is again 1. So this is the answer. Check it for the 2. That's all. It can also be done. This very complex question can be done in a minute. This question can also be done in a single minute if you do it only for the two input checks. Because then there is no need to go for the third check. It would have been first would have do if this would have been like this. It would have done, the first would have done. Okay, let me go to another question. This is the product. This is Q is equal to V is equal to this, F is equal to this. What will be the complete expression for it? हमें B का expression निकालना है. You must know, देखो, you see, if you do it through a procedure and find the values, it will be done. It will be done. I can substitute the value of F like this, and will V cross B I will substitute, and then I will go for the expression. Within 3 or 4 or 5 steps, the question, the magnetic field expression will come out, and you can just write it down. But you don't have time. So what you do? You know, magnetic field must be perpendicular to force, because that is the property of the force in the magnetic field. F is equal to Q V cross B. So V should be perpendicular, F should be perpendicular to V and B. I will put B here and make a dot with F. If that is 0, that will be the answer. Here, if I dot with F, okay, let me dot this with F. 8 4s are 32. 8 20s are minus 160. Minus 6, it is 72. No, it is not 0. So this should not be the answer. I can check out, but see here, let me see the answer. This cannot be the answer. This, let me check it fourth. 6 into 4, that is minus 24. This 6 into 4. 6 into 20, that is plus 120. 8 into 12, that is minus 96. If you add these two, it will become this 0. Yes, this is the answer. So the method is, the magnetic field is given. Make the dot product of this magnetic field with the force. Make this dot product of the magnet with the force. Anyone comma 0 is the answer. He cannot give you two magnetic fields which will make 0 with the force, because that will be the same magnetic field. So his condition is also, his options are also limited. He cannot give you two magnetic fields or two things which are perpendicular to the force. He can give you only one. He cannot give you two. Right? So this is the answer. Now a car starts from rest and accelerates at 5. At t equal to 0, a ball is dropped of a window by acceleration of the ball at t is equal to 6 seconds. 4 seconds, 6 seconds, and 5. I remember this. Okay, have a look. It's a car here. It's a car here. And here is a person. Here is the person. Here is the person. He drops a ball. The car accelerates with 5. After 4 seconds, he drops a ball. But the question is, after 4 seconds, what will the velocity? Okay, that we have to see. Once he drops the ball out, the only thing that you must know, once he drops the ball out, the ball is only under gravity, so acceleration will be only 10 g, that is 10. That is all. So if I have 10 acceleration in the answer, only 10, this must be the answer. Because once he drops the ball out, so the only force acting on the ball is gravity. So acceleration due to gravity, that is 10. Anyway, I will get this answer also. But here you can just check it out like that. So after 4 seconds, yes, and then after 6 seconds, the ball is dropped. After 4 seconds, the ball has a forward velocity of, that is v0 plus 80. 80, v0 is initial velocity is 0, a is 5, t is 4, that is 20. But it also falls down. So after 6 seconds from the start, how much is the vertical velocity? That is gt. G is 10. What is t? That is 2 seconds, because he says after 6 seconds. From 4 seconds to 6 seconds, there was only 2 seconds. Again 20. So it is 20 and 20. The net velocity is root of 20 square plus 20 square. And that is 20 root 2. So once the ball is released, after 4 seconds it has a forward velocity. And after 2 seconds falling, it has a vertical velocity. Forward velocity is 20. Vertical velocity is again 20. So net velocity is 20 root 2. That is the answer. Okay. Now see the question. 3 resistors shown, R2 are the resistances. We have to find R3 by R1, ratio of this current to this current. That we have to find. That's all. So I will try to solve it here. What's current I2 and what's current I3? I2 is to I3 is equal to, okay, that is current here, that is voltage by R2 resistance is to voltage by R3 resistance, because voltage by resistance is the current. Voltage across this resistor is the same as across this resistor. Voltage cancels off, so I2 is to I3 is equal to 1 by R2 is to 1 by R3. So let me go to here. I2 is to I3 is equal to 1 by R2 is to 1 by R3. Multiply R2 R3. So go, when you multiply here R2 R3, here R2, so go R3 is to R2. So for current I3, it shares the resistance of R2. I2 shares the resistance of R3 because it is inversely proportional to the resistors. So what is I3? I3 is this R2, the resistor which it depends on, divided by sum of the two resistors into input current, that is I1. So I3 by I1 is equal to R2 by R2 plus R3. Answer R2. This is the answer. A point object is placed at a distance of 6 centimeters from a convex lens of focal length 30. If a plane mirror were put at a perpendicular to the principal of the lens, principal axis of the lens, at a distance of 40 centimeters from it, the final image would be formed at a distance of. The question is like this. Let me solve the question like this. 60 and 40. I must remember this. 60 and 40. This is a lens. This is a mirror. Okay, let this be a mirror. This is the object at 60. This falls here. This is 40 centimeters. I want to find where this lens forms the image. If it forms here or here, let me see. Where it forms the image. 1 by V minus 1 by U is equal to 1 by F is the lens formula. 1 by V minus 1 by U is equal to 1 by F is the lens formula. This is the lens formula. 1 by what? V, that is, okay, what is 1 by V? That's minus 60. Minus, no, that I had to find. So 1 by V minus 1 by minus 60, because it is on the left side, is equal to 1 by F. What was the focal length? Focal length 30. 30 was the focal length. Okay, 30. What is 1 by V? I want to find image position by this. Why it forms the image. Okay. Now 1 by V is equal to 1 by 30 minus into minus go plus. It will go to the right, will again minus 60. So it will be 60 LCM. It is 2 minus 1. You go 1 by 60. So V is 60. That means final image is also formed at 60 centimeters from the lens. So it will be from here 60 centimeters. That means it will form image here. Here 60. It forms the image here 60 centimeters from here, from this lens. But there's a mirror here. That means ray of light will not be allowed to cross. It will be reflected back. It will be reflected back the same distance as it would go. From here to here it is 20. Because from here to it is 40, from here to it is 20. So the ray of light wanted to go over here. I don't want to use second equation to find this. It will be reflected back the same distance, 20. So image will be formed 20 centimeters away from the mirror. Yeah, 20 centimeters away from the lens. That's it. It will send the image here 60 centimeters away from the lens, but there is 40 centimeters distance mirror. So the ray of light will not go here. It had to go here. It will reflect back the same distance because of the plane mirror. It will send it. It had to go over here, but it will send it the same distance backward at 20 centimeters. So let me find out the answer. 20 centimeters from the mirror, also 20 centimeters from the lens. But I want to see the correct answer option. 30 centimeters from the plane mirror, no. 20 centimeters from the plane mirror, and it would be a virtual. Yes, this is the answer. This should be the answer. These were the questions. I have discussed all the questions, and there's none questions now remaining. So you just do it again. You just do these questions again and see if there's any problem. You can ask me questions on this in the next session. And I think questions are very easy, but some of the questions are very lengthier. But I try to cut them short and try to show you those techniques which can solve the question in the short time. Okay, thank you.